Good morning, good afternoon, and good evening, everybody. Thank you for attending our webinar. I'm Kevin Jones from Ectobox. We have Frank Galuska also from Ectobox and Dave Schultz from Spruik. We are here to talk with you about the Unified Namespace. So I really appreciate you coming. I hope this is valuable. We will, Kai and Clocker on our side is going to be pushing up a couple updates throughout this process to let you know about a couple of things. We'll send out some updates after the webinar. But let's get right to it. So as a matter of introductions, this is going to be the first of a series of webinars on the Unified Namespace. This is part one, and we're going to define the architecture and the asset models. And in this process, I'll just give an overview of what the series is going to look like. We'll talk about the Unified Namespace a little bit. I'll give a little background information on it. We'll do a bit of modeling, and we have some prepared questions, and then we'll open it up for Q&A. For introductions, I'll just say just a little bit extra here. So I'm Kevin Jones, CEO, founder, chief strategist at Ectobox, and we're if you will, a manufacturing intelligence solutions company. We help manufacturers operate more efficiently and grow by doing the kind of work that we're going to be talking about here. You could also think of us as an Industry 4.0 systems integrator. Frank is a senior IoT engineer. I should have put the senior here. Sorry, Frank. I'll put that right there. And Dave, do you want to give yourself a little bit of an introduction?
Yeah, so I don't know if how many people are aware. So I started G5 Consulting, and at the first of the year, I joined with another company called Spruik Technologies. And I am trying to think of my exact title, but I end up doing the exact same types of things, doing solution architecture, help companies digitally transform, and then building unified namespaces, putting in all of the technology in order to digitally transform their operations.
Awesome. Cool, good stuff. All right, so for the series, the idea is that we're going to help people understand what the Unified Namespace is and how to actually execute it. There's some content out there that Walker Reynolds and I think maybe a couple others have put out. We're going to and we've already done some videos, some webinars on our own on our YouTube channel, and also did a nice joint session with HiveMQ as well. But we're going to dig deeper and longer on this. So we're going to do a webinar probably about once a month, and we're going to go through a series of sessions to dig into the depths of how to set up the unified namespace, and also to connect things together and to get the how to do that connect, collect, store, analyze, and visualize by connecting multiple systems, not just a machine, but other systems as well. So this session is the first one, planning the UNS and some concepts. Then the next one, we'll get into looking at the machine, connecting with the machine to finalize the UDT that we'll be talking about today, and finalizing the edge namespace. We'll review and plan out today. We'll get into how to develop a small solution to connect with it in Ignition or Factory Studio, start to do that connect, collect, store, analyze, and visualize idea. And then subsequent videos, maybe we're going to be doing downtime and OEE with an MES, and maybe we'll connect with the CMMS via an API and do a maintenance work order and pull data from the CMMS and connect with an ERP, maybe make the UNS queryable, if that's a real word, maybe look at business intelligence. And I say maybe because we will reserve the right to change our mind, but this is the basic idea of what we're going to outline and go through in this webinar series. And we're really looking forward to this. There's been a lot of a great reception about this. Background, we're going to go through things pretty briefly so that we can leave enough time to get into the real meat of things. So as a company, we connect to everything without vendor lock-in to really drive that true data-driven manufacturing idea. And when you think about doing that, it's helping companies move from where they're at. They have connected and automated machines. In fact, a plant that we were at this morning, and help them move to not only automating the machines, but automating the business, and doing that with the data. Data is behind everything that's in Industry 4.0 from our perspective. And doing this movement is what we think of as a digital transformation. But when we're doing that digital transformation, this is often what we find. Silos of data, disconnected data, discrete connections between systems, which are very expensive, and very often an ERP system that is at the center of the world. And, well, maybe it shouldn't be. The ERP isn't really the single center of the world or version of the truth. What we like to do is to think in terms of a unified namespace. Let's connect to everything and then connect everything to that single point of truth, if you will. And that single point of truth becomes that unified namespace. And what we do is we implement this using event-driven architecture, publish and subscribe, so that anything like a PLC, an MES system, et cetera, can publish to this single version of the truth there in the middle, and everything else can have access to that data. You then eliminate those discrete connections. Everything is, I forget what the phrase is, but disconnected from all the other systems directly, and you have them all connecting to a single central system. And to take this idea even further and to make it better, we then model the data. We organize the data within the plant using the unified namespace idea, and specifically organizing the the data by the enterprise, site, area, line, and cell, borrowing that idea from the ISN 95 Part 2. That's the piece that we're going to get into. So what is the unified namespace? It really becomes that single central hub of communication, as I often throw my hands around in the air and pointing to my palm. That's the hub. And in that hub, we have the structure and events of the business, which is the enterprise, site, area, line, cell model of the business from ISA. And that data is available. The current state of the data is available, and that then becomes the single source of the truth. And based on all of these pieces coming together, then this ends up being what we think is a very strong foundation for digital transformation initiatives. And when you start to implement them, this is what they can often look like. Now let's get to the fun parts. So when we're thinking about a digital transformation, 3 big stages. There are lots of different ways that we look at it, but we'll break it out into 3 big stages. Education is absolutely critical for digital transformation across the whole organization, so everybody understands what's going on and the value, the power of being able to have access to that data to innovate with, and most importantly, to take action. Second piece is strategy and architecture. And we go through, Dave does this kind of work as well, go through a digital transformation maturity assessment, DTMAs. And the outcomes of that DTMA is one of the most valuable pieces is a digital strategy. Leadership saying they value data, and here's how we're going to use the value of that data. And then that you develop from that minimum technical requirements and other things which become what we think of as the digital roadmap, or excuse me, digital guardrails as you go down this path of digital transformation. And from that comes the architecture. Once we have the strategy and the architecture defined, then let's get to solving problems. And that's what we're going to start to do today. So the process for solving a problem, as you can see on the right side of the screen, is to define a problem to solve. Then at that point, let's take that first project, that proof of concept. Let's launch that project. And in launching the project, use some good project management concepts, project charter, RACI matrix, and a style of project management, maybe vanilla Scrum, or a little more agile process, incremental process than a true waterfall process, so that you can iterate not just through the project itself, but also through the whole transformation process. Then at that point, a good thing to do is to do a site survey. Let's step back, take a look at the machines, the process, understand how it works, potentially get drawings of the machines. How does it work? List of points from the PLCs, and then be able to understand what we're working with here. The next step then is to design, do the design work, which includes creating a functional and technical specification documents, defining the functions, the capabilities we need in this project, in this particular proof of concept, if you will, and also maybe even going as far as creating a couple wireframes, what things look like. And then at that point, we design the UNS and we start to model the equipment and assets. That's the piece where we're going to focus on today, of course, highlighted there in the list. And then after that, we start to install the software and hardware, can do the configuration, et cetera, get into the machine connectivity, get the data reporting up into the UNS, and then do the development of the rest of the solution, do the local testing and acceptance testing, factory acceptance testing, commissioning, and then you're live at that point. At a high level, that's typically how projects run for us. I know a lot of you have gone through this process before, but some of you, it might be helpful just to get a basic idea of how all that works. So let's get into the fun stuff. Let's say that we've defined our problem to solve, and we've launched the project, we've done our site survey, we're looking at our machine, and we're looking at a bottling line. And within that bottling line, we're looking at a capper. We'll set the picture a little bit later in one of the next sessions, and we'll get into a little bit more about the functional spec potentially. But right now, I really want to cut to the chase and talk about UDTs, modeling the asset, and getting into the edge namespace. So let's say we have this capper here. We actually have this demo or simulation of a capper running in Siemens S7-1200, I think. And we're connected to it with the Siemens TIA portal. And we actually have this nice HMI visualization of how it runs. And if we were to run it live, you'd actually see this running. So with that capper, then we have a lot of data available. And what we want to do is to start to plan out how we're going to connect with it. So Frank has worked out a basic, well, Frank, let's start the questions. Would you think of this as a UDT that we're looking at here for the capper? What are we looking at?
Yeah, so this would be a user-defined data type for that piece of equipment of the capper with its subcomponents or underneath it, also composed of UDTs or just sort of singular tags from the machine.
So when we think about doing this, and I meant to go back and ask you guys for a little bit of feedback here in this process. So when we're looking at that edge namespace, this UDT for the capper, are there any comments that you guys have in this whole process that I talked about? Any blank spaces I left? Any additional comments you want to make about any of these steps, or should we just simply get into modeling the equipment and the asset?
Yeah, there's actually a couple of comments I did want to make on that. So one of your earlier slides, around how we start connecting everything into this unified namespace. There's a concept that we want to utilize, is that we're going to take all of our intelligence and connect it to technology, meaning we're not going to take all the smart stuff in the business and bring it into a platform where that now becomes sort of this monolithic application that now controls everything. We want to use technology, so these nodes within this ecosystem can all publish and subscribe, and it becomes this many-to-many data transfer. So that's one of the just comments that I wanted to make on that. In terms of actually building out a unified namespace, so you've talked about the whole, how do we solve a problem? I usually start with the question of, is there actually a problem we're trying to solve? And then we're going to solve a problem. And most of the time in these DTMA, or the outcomes is, there absolutely is a problem that we need to solve. We're going to do these things iteratively. So building a unified namespace just starts with some basic concepts. We start with, sometimes what comes out of these DTMAs is a proof of concept, and it's that connect, collect, store, visualize, analyze process that you pointed out there. In order to start getting everything, it's the connected and collected piece, and it always, generally starts with modeling some of the assets, and that's actually what we're looking at here.
Good comments.
And then we can start adding in some of these additional
Good,
features.
Awesome. Yeah, I can remember distinctly back to a company manufacturer that we worked with a number of years ago, $3 billion, $5 billion company, and the CEO worked with one of the big consulting firms and said, "I want to improve my company." The consulting firm said, IoT, you should take a look at it. And then the CEO turns around and says, "Go forth and IoTize." And these engineers say, yes, sir, 3 bags full. And then they start immediately looking at sensors and trying to pull as much data as possible. And they got themselves so wrapped around the axle and never really figured out what problem there was to solve. And it didn't take much to have a brief conversation to say, "Guys, look, what are you trying to do here? What problem are you solving? Let's start there first, and then we can work down the rest of the stack." So great point, Dave. Thank you very much.
Yeah. Adam brought in on a question about when you say intelligence, meaning the ERP, CMMS. Yes, so that's all the smart stuff in the business. It also means people as well. You want people that are going to connect into these technology stacks that are going to consume that information. So it's anything it's all data driven manufacturing. It's all actionable information that it causes somebody to do something, and that needs to be all informed through this this technology that we have that's being done within the unified.
So you're
namespace.
kind of considering them, Dave, as the people are maybe another node in this whole ecosystem here. Yep,
yes.
absolutely.
Absolutely, they are. Yeah, yeah, and we'll get into the later webinars that some of the data models that we're creating in this unified namespace. There are the visualization pieces, or there are the informative pieces of it's meant for somebody to consume this information in a pre-structured, predefined way. So it's just a matter of whatever your window of your operation of choice is, you'll be presented with that data in that right context, based on your role, based on an event, based on even where you are within your manufacturing process. All very, very relevant pieces.
Yep, makes sense. I'll just going forward, I'll make my change to my UNS diagram. That's a good one. Frank, go ahead.
There we go.
Yeah, I was going to say, I think the other important thing to note here is that the UNS is not like a database. It's not storing this data. It's merely a way for all these nodes to publish data and other nodes to subscribe to it, and sort of the UNS is routing the data from node to node. It's it itself is not containing and storing this data for long-term use.
Mm-hmm. Yep.
Just another kind of unique
great
difference
point.
between this architecture and what Kevin had on the previous slide, where everything's kind of focused around maybe your ERP or siloed.
Yep. I'm not sure if I would call this an architecture.
Commonly known as the data. Yeah, what you're describing there is commonly known as a data hub, which certainly there'll be something like that as a part of it. But it's the whole point of it is that the single source of truth is that the data that's transmitting, everything that's creating intelligence, consuming intelligence, that's all done through this unified namespace architecture and technology.
Yep, absolutely. Okay, let's get back to the purpose of why we're here. Not that that wasn't valuable. That is really helpful, especially for a first video on the series for the unified namespace. Now let's talk about modeling. So we have that UDT defined. So let's say that we've actually have done the functional spec, the site survey, we have the list of points, we have the drawings, etc., and we're ready to start modeling things. What's the next step? We're looking at this machine, we have the tags. What's the next step? Frank, do you want to touch on that a little bit, and then Dave, a little bit of back and forth here?
Yeah. So, my typical approach, I like to start at the lowest level that I can think of, right? So here we kind of identified some sensors, some inputs to whatever's controlling this capper machine, and identify what components of those sensors and what data around those we really care about. So we have a heater temperature here that's bringing in a set point and a PV, or present value. And along with that, maybe there's some alarm parameters of a high alarm, low alarm, and deviation alarm. So that's really where I like to look at it, the lowest level, and kind of build it up from we get the equipment overall.
So then when we're looking at what we're going to do in our next session is to dig into the tools and say, okay, let's get into Factory Studio or Ignition and actually start to build this out. Today, we're really kind of planning this process out. Once we've defined this, we've defined the UDT, like where are we typically doing that? We'll see it next time, but can you talk through a little bit of where you're doing that and how it works at a high level?
So there's a couple of places that you're going to have a UDT defined. Certainly UDTs are not a foreign concept within PLCs, and typically they're more around the whole control of the process itself. So a timer is technically a UDT. There's 4 components that make that up, of what's the upper limit, what's the current state, and if I'm rising or lowering. So there's 4 pieces there. When we start talking about UDTs, really it's more generically, it's a data model. So we're trying to bring together information that maybe isn't all coming from the same source, or there's some other context that we want to add that's a part of that value. So what you're seeing here on that capper is you have temperatures, and I'll oftentimes will model the variables, the process points that are set points within my controlled process. If I have a recipe, I've downloaded that recipe, there is what it should be, and there's what it actually is. Well, so those are two pieces of information that you want to have that are in context with each other. But you also want to know what's my upper limit, what's my lower limit. You also want to know, am I in an alarm state, whether it's a high alarm or a low alarm based off the process value. And as I mentioned, when you're in deviation, you want to know that as well. That's typically not done at the PLC. That's something that's going to be brought into your IoT platform of choice. You've mentioned Factory Studio or Ignition. There's another tool called Neuron that can do the same type of thing. And that's where you're going to start bringing through this unlike data, make it like data. It's known as normalizing data and contextualizing the data. And you want to model as close to the problem you're trying to solve as you can.
Good. So I'm going to jump down a little bit. We have a few questions to throw around here. You've already started to talk, David, about what a UDT is and getting a little bit into how to create it. Frank, just real quick, SP and PV. I think SP is set point. You want to talk about those a little bit within this UDT?
Yeah, Dave Schultz was just kind of touching on that as well. So set point is, what your temperature should be at ideally.
Sure.
And then your PV or your process value is, what it currently is. And, ideally your your process value should match your set point. But that's not always the case.
So if we're talking about a namespace, and we want to build up our UNS, and the UNS is going to be made up of a variety of namespaces. I've started to define the one that we had on a previous screen. So let's say we have the enterprise, enterprise site area line cell. Enterprise is Coca-Cola, site is Pittsburgh, area is bottling line. And then at that point, we're probably picking a specific bottling line. So work with me, guys. This is where we'll just do a bit of back and forth. So we would have bottling line 1 maybe, and then under that bottling line, would we have the asset here, the capper? And where does this go in this whole structure?
Yeah. So at this point, within a lot of the technology building it out, it's going to be a combination of folders as well as some data models itself. So you're probably going to have a capper folder that includes other namespaces. And within that folder, and this is where it gets a little confusing, there might be a capper UDT or a data model. And those are the things that you want to have common across every capper within your organization. So as you start to compare cappers in different lines, cappers in different plants, you can look at a semantic data model that tells you about how is this capper running? So it's my process state, it's my process health, it's my asset health. Those are the types of things you want to get. And then, of course, energy and the labor that's associated with it. But there's other namespaces that we'll be talking about in future videos that would likely exist within this bottling line 1. Many of them are the transactional data that we'll get in. So you talked a little bit about some of the MES functionality. You're going to have some of that is going to be part of that bottling line 1 model. You're going to have, maybe there's some material movements. There's going to be a maintenance work order. I mean, there's just a ton of things that are going to exist there. But before we get too far off into the weeds on that, this is why we start with just modeling the asset. We're just trying to connect and collect some data, but try to get it built up. And it'll be iterative. We'll add an additional.
Yeah, I definitely don't want to get ahead, but just to give an idea of where this kind of fits into things. So this is at just under the bottling line at the capper level. We'll have is that where we would have the various OEEs, the work order, maintenance work order, that kind of thing?
Yeah, a lot of your the line namespace, if you will, is going to have quite a bit of information in it, because when you think about the ISA 95 Part 2, that's where a lot of the functionality, that's where we're actually performing the work for that manufacturing work order. What you'll probably see under the capper is also, I mentioned earlier about, that's your CMMS could be a part of that. So maybe there's a downtime event that's on that particular piece of equipment. That's where you'll also see, a maintenance work order that's associated with that bottling line. That's also very
sort of like that. Mm-hmm. Yep. Okay, good. Frank, anything else to add to the structure and how it starts to fill out?
Yeah, I just want to kind of round out the picture a little bit more here. The capper UDT that you have over there on the right, that underneath that or inside that UDT is where we have the specific PLC information that we're defining on the left. So, and that's where our heater temperature comes in, our pressure sensor, our limit switches, all that edge data.
Would we maybe call that an MQTT namespace or an edge namespace at that point under the capper? And that would be the collection point for all of that data? Is that how it would work?
Yeah.
Okay, so then...
that's where all the data from, that device would be located.
Okay. So then heater temp and set point and process value and et cetera, all would fall under that structure then. Dave, concur?
Right. And then
I tend to use edge. Yeah. Go ahead, Frank.
No, go
ahead. So I tend to call it an edge because my technology may or may not be MQTT. Very common, mostly through I just noticed the comments in here. There's always the minimum technical requirements. So we want to use the open, lightweight, report by exception, edge driven. There's a number of protocols that support that. What we have seen within manufacturing automation is MQTT, either flat or with a spark plug B specification payload. We'll see both of those. So it tends to be fairly common, but I like generically calling it edge because that then gives me the opportunity to change something in the future.
Nice. Good.
And I wouldn't want to have, say, a DMP3, namespace that's called MQTT, right?
Good. Makes sense. Mm-hmm. All right. So then where do we go from here? We've defined our UDT. We have our namespace. We've talked through the unified namespace holistically, excuse me, and where the capper lies and where the edge namespace lies within that structure. What else should we be covering here?
So because this is a capper, you're going to have bottles that are coming in. So you're usually going to have counts that are associated with that as well. So you're not only going to have your set points for, say, the temperature or some pressures. You're probably going to have some rates that are going to be associated with the actual performance of that particular piece of equipment based on the recipe. So recipes are specific to a particular product or material definition, as well as a specific piece of equipment, or if it's identical, a family of equipment. So you're going to have rate values in there as well. And that helps define how is it, it's the process health. I'm supposed to be at 100 bottles a minute. I'm running at 80 bottles a minute.
So, excuse me, at the same level as the edge, I've got counts, I have recipes, and rates you're saying rates are a part of a recipe, generically speaking?
Rates are going to be, yes.
Okay, good.
Yeah, I don't want to get
into a big here forever.
Conversation around that, but yes.
Good. All right, let me, I appreciate you guys watching the comments too. So what's next? I think, where do we go? So we've covered pretty much all of that. What's next in the unified namespace and why, and how do we determine it? I think at that point, that's where in the next webinar, we'll get into maybe a little bit more about a functional spec, saying, okay, this is the problem to solve. Here's how we're going to solve it as a functional spec. Here's the actual UDT, and we're going to get that to flow into an actual unified namespace, and we're going to actually connect to the machine and get the data to flow and actually see it flowing from our simulated capper. After that, at that point, are we essentially getting back to what are our next steps? Okay, now then at that point, we're connect, collect, store, analyze, and visualize, and maybe we'll, just as a quick demo, pull the data into or display the data into a basic screen in Ignition or Factory Studio or Neuron, and maybe show some wiggly lines or something, or get the data from the MQTT data broker, subscribe to it with Canary, and again show some squiggly lines there. Is that the next step? And then after that's when we start to define some of the functional namespaces for the MES capabilities, et cetera. Is that the next step, or is there something else in between?
So I would expect on a line, there's going to be one, more than one asset that's there. So is this, as we're doing these, modeling the assets, this is your assets, modeling your equipment. It's as the line is getting built out, we need to now start modeling all of the data that's coming off the capper. There's probably going to be, we're going to assume this is a bottling plant. There's probably going to be a filler. There's probably actually the batch. So there's a batch of product that's coming in. We're going to have that modeled, is associated with that. And then there's also, maybe there's a case packer or a palletizer. I mean, there's a lot of equipment that's generally associated with a bottler, and it's getting all of those types of things mapped in there as well. But this is what I would at least start with, because this is the early in the connect and the collect piece, and we just want to start modeling all of our information as quickly to the asset or as closely to the asset as we can, because the asset's going to know what kind of data is there. And that's what I at least focus on, is mostly your, any of your process variables, any of your real-time tags that are going to be telling you information. I would model those within the context of an asset.
Good. All right. Well, we'll have a more filled out edge namespace prepared next time, and then we can start to continue with that connect, collect idea, et cetera, in the next session. Frank, any other ideas that we should add to this?
No, I think that's really kind of going off what Dave was saying. Once we have everything modeled and everything around that line defined, that's really when we start to build, start developing some visualizations and start working on the other namespaces as far as, OEE and some of the functionality we need to bring in to solve the problem.
Good. Awesome. Great. So
There's a couple of questions that have shown up real fast, Kevin. Mm-hmm. So a question was asked, what is flat MQTT? Yes. So Frank, you want to maybe talk about that?
Yeah. So two different kind of, variations of MQTT. Flat MQTT is essentially just kind of raw JSON or any really text sent using the protocol. More sort of developed and standardized method of publishing data is using the Sparkplug-B protocol, or variation of MQTT, which really defines, how the payload is going to look. So you're going to have certain metrics in certain locations. You're going to have things like a birth message, a death message, to tell you if your connection's good or not. You're going to have your timestamps in a certain location, that type of thing. So those are really the two differences between flat and Sparkplug-B, and based on the added functionality and sort of definition that Sparkplug-B provides, we try to use that as much as we can.
It reminds me of the comments I've heard Arla Nipper say. Arla Nipper, one of the two co-founders of MQTT. One of the greatest things about MQTT is that it's really flexible. And one of the worst things about MQTT is that it's really flexible. So you can easily give yourself enough rope to hang yourself by making by not having some structure to work with. And Sparkplug-B helps with some of that structure. Dave, any other comments beyond what Frank said?
Yeah, no. So it's flat is just is the name would suggest. It's a topic namespace that is built on the original MQTT specification that was developed in the late 90s. So if you think about a folder structure within your say Windows Explorer, and you drill into those topics, if you were to actually look at that file structure in a like a command line, like a DOS interface, that would be the actual folder structure. That folder structure is what your topic structure would be. So think of a flat MQTT like that. And as you mentioned, the best part of it is it's, you can publish to any topic. The worst part is you can publish to any topic. And that's where Sparkplug comes into play. It starts to put some rules around how we're going to publish and subscribe to all this data in a way that we all agree on. So information arrives at the same place that we would expect.
Good. What other questions do you guys see coming through?
So somebody asked earlier about, can you do a UNS in OPC? And I actually have a couple of answers on that. For me, yeah, it's OPC is, I use OPC a lot, especially in coming off of plant floor data, PLCs. Oftentimes there's some type of OPC server that is providing that connectivity to whatever that hardware is. But once I get that data connection into my IoT platform, that's where I will no longer use the OPC technology. And it's mainly because it violates the open lightweight report by exception piece, is that OPC is more of a pull response. That said, you will see OPC being used in certain industries where, moving data back and forth. So a lot of process industries, you'll see OPC being used a lot more. Wouldn't necessarily call it a true UNS, but you can use the protocol for it. So just, it's a nuanced piece of it, but for the most part, OPC is not used for building a UNS.
Good, fair answer. And I'm just reading through some of the comments now after looking at the slides, and this is great that people are answering other people's questions. Awesome. So love the participation with everybody. That's awesome.
Yeah, and Sparkplug, the specification is absolutely, you can download it. It's an open protocol.
Yep.
Yeah, and they just released version 3.
We're not doing...
And so it also provides support for MQTT 3.11 and MQTT 5.
So we're not doing the Sparkplug ABC. Now we're going from AB3. That's how we're working it now?
I think it's still Sparkplug B, but it's the 3.0.
Okay.
I guess I'd have to look at it.
Okay, good. Any other questions that you've seen breeze by that we haven't answered yet?
No, I think so. Since you asked, I'm gonna grab it and look. Oh, yep, it's Sparkplug 3.0.0.
There you go.
So there you go.
There you go.
All right, good. When is the next seminar? Great question. TBD. We don't have a date defined yet. We will have one defined by the end of this week. Because Kaing is going on vacation soon next week, so we're going to get it defined and then get it out to everybody. So it's a great question there, Kasim. Thank you. Anything else to wrap it up, Dave or Frank?
Yeah, no, I think the next webinar that he asked about, it's really going to be, now we've modeled edge and data, we're going to start taking a look at some functional namespaces too. So functional meaning it's taking some data, doing something with it, and presenting that information back. And that's where you really start getting into the power of the unified namespace.
Yeah, good. And really appreciate the comments and compliments, Dan, Adam, Kasim. Really appreciate you guys attending. It's a pleasure to do these. It's really a lot of fun. So thank you, everybody. And especially a huge thanks to Frank and Dave for coming on. We'll get back to you, everybody, with the next date, and we will keep marching on. Take care. Bye.
Enjoy.
All right. Thank you.
Thanks for your time, everybody.